Hello and welcome. In this video, we're going to do problem 6A of lesson 9 for Math 48A. Specifically, we're going to try to solve this radical equation using a graphical method. Remember, in our graphical methods, we have five different steps, and we're going to follow those here. So specifically, we're going to graph the left and right-hand side. In this case, the left side, we're going to call, we'll write it in blue, and we'll call it the square root of x plus 5 minus 1. So that's the left side. And then the right side is just 2. So we're going to write y equal 2. One of those is a lot easier to do than the other one. Specifically, y equal 2, there's no x value in that. So when x is -6, what is y? Well, it's just 2. When x is -5, what is y? Well, it's 2. Y is always 2. So specifically, this is what we say is a constant function. There's no change in x as we change, there's no change in y as we change x. So if I look at -6, 2, -6, 2, -5, 2, -4, -3, -2, the y value is always constant. So specifically, we see that y equal 2 is a horizontal line at the number 2. This one is a little bit harder. The square root of x plus 5 minus 1. In order to graph this one, we actually might rely on our calculator. So in this case, we're actually going to go over to our calculator, which we see on screen here, and we're going to set y equal. In this situation, we're going to use the square root, which is right above the square. It's in blue, so we'll go ahead and write second square root, and we're going to type x plus 5. Close the parentheses, and that says that the radicand is x plus 5. And then outside the root, outside the radicand, we want to put a -1. For good measure, let's go down and put a 2 here. Now remember, we're trying to get this entire table using our calculator. Well, there's a table button here, so we're going to go second table. Notice that we can get some sense of what this table looks like. At -6, the thing is an error. So this is what we say, error, or we could say undefined. At -5, it is -1. Let's go ahead and check. -5 plus 5 is 0. Square root of 0 is 0. -1 is -1. At -4, -4 plus 5 is 1. Square root of 1 is 1. 1 minus 1 is 0. So that checked out. Some of these other ones are kind of nasty. -3, -2, they look like basically what we call irrational numbers. And the reason that that is if I put a -3 here, -3 plus 5 is 2. Square root of 2 is not an integer. So this is what we call square root of 2 minus 1. And my claim is square root of 2 minus 1 is 0.41421, blah, 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 blah. And that's what the calculator is reporting here. Similarly, if I go to -2, -2 plus 5 is 3. Square root of 3 is not an integer. So this actually thing is square root of 3 minus 1, which is the number we see on our calculator over here. And then -1. -1 plus 5 is 4. Square root of 4 is 2. 2 minus 1 is 1, which is exactly what we see. And in fact, we can kind of highlight the integer values. So here we have 4, 2. So at 4, this thing is 2. And then the rest of these are really non-integer values. So I'm going to guess that this is going to be like square root of 5 minus 1. And I suppose for fun, we could actually write this as like 1.4495, and it goes on. This one is like 1.6458. and it goes on. Let's see, square root of 5, square root of 6, square root of 7. And then I guess this is going to be the square root of 8 minus 1, square root of 9 minus 1, square root of 9 is 3, minus 1 is 2. And then this would probably be the square root of 10 minus 1. And maybe we say that we get the last one in numeric values. So that's going to be 2.3166, 2.3166, dot, dot, dot. Now, what we've done here is we've gotten a table of values for the right-hand side, which is in red. The left-hand side is in blue. We can actually kind of check this. At -5, the thing is -1. -4, the thing is 0. All the way to 1 goes up to +1. 4 goes up to 2. And we've got this root function. And that root function kind of goes up in that direction. And what I wanted to highlight is we actually know the description of the graphical method, which is right here. What we've just, what we've just done is we've graphed the left-hand side, we've graphed the right-hand side. Then we want to find the points of intersection. So in this situation, we have one point of intersection, and it's right in the center here. So we notice that that point of intersection, maybe we'll do it in pink, that point of intersection represents the input value where the two outputs are the same. So the blue output touches the red output. So here we say point of intersection is at input value 4, output value 2. That's exactly what we saw in pink here. And then remember, in our graphical method, when we're trying to solve this equation, we're literally trying to find the input value x that makes the left-hand side equal to the right-hand side. So another way to say solve this equation is find input value x such that output on left-hand side is equal to output on the right-hand side. So what's that asking? So we'll check this out. If my input is 4, my output on the left-hand side is 2. If I put in positive 4, 4 plus 5 is 9, square root of 9 is 3, 3 minus 1 is 2. So x equal 4, the value of 2 is on the left-hand side, x equal 4. Well, x doesn't show up on the right-hand side, so the right-hand side is always 2. Indeed, 2 equals to 2, and that's why we say we have a solution. Remember that when we solve an equation, we always write our solutions as x equals something. So in this case, we're going to say our solution to this equation is the input value x equal 4. I'm sorry, do you see it? X equal 4, not 2. And with that, we've actually solved our equation, and we've just checked that work verbally. All right, this ends this problem. We'll go ahead and go on to the next problem in the next video. I'll see you there.